submissions that people have made to oppose fracking over the last few years. There's been numerous petitions, pamphlets developed, people have set up tables at the market, groups have formed, people have met with politicians, people have done a lot of contributions to email lists of good articles and that kind of thing. So this event is just another event along that long continuum of history, and I hope we end up being successful. So we put this event together as a way to make a little bit more public the tremendous amount of knowledge that's within this, the North Shore community. People that you'll be hearing from today will be sharing kind of the high points of the submission that they intend to make to the Nova Scotia Review on Hydraulic Fracturing, that's also called the Wheeler Commission. So they'll be sharing sort of the key points of their individual submissions. So so it's an opportunity to learn from the work that these folks have already done, and maybe get inspired to write your own submission. And that's really kind of we do have an agenda here. We're hoping that lots of people become inspired to write your own submission to the Wheeler Commission. We will have a short info piece about the commission that Barb Harris is going to offer us after the presentations. So you'll hear a bit more about the details of that in an hour or so. We're also hoping, if time, this will be maybe, if we don't have time, we'll have to ditch this idea, but we do have a new video that's fairly inspiring about the nonviolent resistance that's been happening in Elsipogtog, New Brunswick. It's a very high quality video that the United Church of Canada did, and it's available on YouTube. So if we have time, we each have presentations, and then we'll open it up for a 5-minute kind of questions and comments session, and then we'll have another 3 come up. So thank you again in advance to the people that were willing to offer their presentations today. So I'd like to ask Yuill Herbert, David Boyle, and Brian Galkey to come up and get the ball rolling.
The mission is titled Natural Gas, a Bridge or a Gangplank, and it's about climate policy. And the references at a bridge and a gangplank both take a bit different worldview on how useful natural gas is in transforming to a low-carbon world. The bridge refers to the idea that we are using a lot of fossil fuels, and they're pretty cheap and they're pretty accessible, and we know we need to use a lot of clean energy, and how do we get there? So the idea that a lot of people had was natural gas is the cleanest fossil fuel, it's now relatively cheap, we can use it as a bridge to clean energy. The gangplank idea refers to the concept that natural gas may actually not be such a clean fuel, and that it may be a gangplank to a very warm and dangerous world. And that's a quote from one of the main critics of shale gas, professor in Graphia, and he wrote that as a New York Times editorial. So of the fossil fuels, natural gas is the cleanest. It's about, when you burn it, it's about 45% cleaner than coal, 30% cleaner than oil, and so it seems like it's a pretty clean fossil fuel. And a lot of people thought that's a great policy step, switch to natural gas from coal, oil, and that's been happening across North America and Europe and so forth. And that was really prior to shale gas. And since shale gas came online, that's changed. And I'll try and explain why that's changed. And this is a subject of great debate amongst policymakers and academics as to what influence shale gas has on the greenhouse gas emissions sort of chain. So when you look at, so when you look at burning natural gas, it's clean. But when you look at the whole life cycle, everything changes. And one of the main reasons it changes is natural gas is mainly composed of CH4, or methane, which is the second most potent greenhouse gas emissions. So it's great if you're able to capture the methane from underground and then burn it. But if any gets away in the process, then you're putting the second most potent greenhouse gas emission into the atmosphere. And so this is the problem, it's called leakage. When you're getting natural gas from a conventional source, it's pretty It's one place, you can control a lot of that leakage. When you're getting it from fracking, you have many wells all over the place, and there's huge potential for leakage. You're going way underground, you don't know what's happening underground, and so the leakage becomes a huge issue. The majority, if you get more than between 2 and 3.5% leakage, natural gas becomes as potent a greenhouse gas emission as coal. So basically, the advantage of natural gas disappears if you get a lot of leakage. And how much leakage is actually happening varies, the estimates vary massively. There's two ways of looking at it. One, you can try and count up the leakage from all the steps in an actual well on the ground, the transmission, the production, and distribution. That's one way to look at it. The other way is to go up into the atmosphere and measure above a city how much methane there is up there. So those are the two ways that they're trying to estimate how much leakage is happening, and they're getting very different results in both ways. When they count it up on the sort of the ground level, they're getting between 1.5 if it's a new well with all sorts of capturing to avoid the leakage, to 17% for older wells.
Wow.
From above ground, they're getting anywhere from 2 to 4%. And the 17% estimate, everyone is saying, is way off. It's probably the most accurate. No one really knows. But of course, the industry is massively attacking those numbers. EPA, which is the US Environmental Protection Agency, which has done a lot of work, has done a study that says it's lower, so 2%-ish. But there's a lot of critique of that study as well. So it's a huge area of uncertainty. We don't know how much leakage is. We know it's really bad when methane gets out. Point one. Second point, our understanding of methane has changed this year. We discovered it's a lot worse greenhouse gas emission than we thought it was. And that means that even that 2% may actually be lower if we want it to be better than coal. Point three is what I call lock-in. If you invest in this type of system, you get stuck in it. It's really hard to go to a different type of system. All of a sudden you have lots of people with lots of jobs in it. You have lots of investment mechanisms. You have politicians who start believing in it. It's really hard to shift once you get there. Is that where we need to go in the face of a warming world? And I'll stop there.